Do we know a conversion that takes us from millimeters to inches? Anybody know in the chat? How do you go from millimeters to inches? That's right. That's perfect, guys. James, Marco, that's perfect. 1 inch is 25.4 millimeters. Just as a 2.54 centimeters. That one is probably ingrained in your head somewhere from conversions last time, hopefully. So I'm not gonna waste time asking. I'm gonna just do it. You please do it on your calculator as well, and hopefully we have the same. So I have 151.18 inches. Can someone confirm? Thank you, Marco. Now, there's a good news here. It says to the nearest inch. You see that here, to the nearest inch? So I don't care about quarter inches and half inches here. So I'm just going to chop off the decimal and leave it as a whole number. And now it becomes easy pickings for you because you know how to convert that to feet and inches. 151 divided by 12 is 12 and something. I know that it's 144. So I'm just going to do this, okay? I'll just type this at the bottom, a little arithmetic time. 12 times 12 is 144, plus 7 is equal to 151. So then I know, whoops, I'm certain that the answer is 12 feet, 7 inches. So I'm not doing anything fantastic there. I'm just relying on my times tables, my 12 times tables. So hopefully that wasn't too dangerous. I have peppered you with a lot of these in the assignments and on the test. So for that reason, I'm just going to move on to the next one. So this time we have inches to millimeters. 1 5/8. So what's 5/8 as a decimal? Perhaps you know that off by heart, but it's 1.625. If you know your fractions over 8, that's very good. It's helpful, especially with measurement. We have 1 inch there, and then we have, again, 25.4 millimeters. So the reason I started off with these two examples, I'm going to write the answer for this one, and then I'll say to you the reason why I did these two examples to break the ice with you today. It doesn't say what accuracy here, so does it say anywhere here? Just bear with me for a second. 3 significant digits, so 41.3. Thank you, Marco. I was just reading the question. In the top of the question of the section, it says 3 significant digits unless specified otherwise. So why did I start off with these two questions? To remind you that there's this method that I talked about last time called the unit fraction method, or if you want, the bracket method. So what you have is that a fraction here is equal to 1. And when you multiply by 1, you do not alter the unit, you do not alter the value. It still stays the same in terms of the measurement. So for that reason, sometimes the fraction's this way, sometimes it's upside down, and it really depends on your objective of canceling out the units of inches here, or in this case, millimeters here. So question F is just a variation of question A, except this time we want 1/16 of an inch. We have done plenty of these ones in the homework and on the assignments. So without delay, let's do this one as well. Now you might be wondering, why are you doing 3 questions involving inches and millimeters? Because these are the things that people complain about in the other courses. The professors are always saying, our students need more practice with unit conversions. So I say, no problem. I'll emphasize more unit conversions in my delivery. And I pass that message along to the other professors as well. So I did this to 3 decimal places Can someone confirm in the chat that they have the same? Anybody in the chat have that? Thank you. Okay. So just a second. So we know the following. I know that 109 inches is equal to 9 feet 1 inch, based on just some arithmetic that I know that you can do as well. So we have most of the answer ready. It's just the 0.449 that is the issue. So recall that we did that fraction trick that I showed you in the past. 0.449 inches. We want here 16th of an inch. So we're going to multiply by 16 over 16. So if I do 0.449 times 16, 22. 22. Okay, hurry up. You're welcome. There you have it. 7 and 16ths of an inch. So we put it all together. Final answer: 9 feet 1 and 7/16 of an inch. Now, I went a little bit faster with these early questions because these are review, or should be review for most of you. And I just want to get you warmed up today for just the last section where the units are a bit more complicated. So I'll just give you another 30 seconds or so if you want to just take down any more information from this page. So I'll just give you 30 seconds. You're welcome, Nicholas. Okay, so we're going to move on now to the last topic, which is mixed units. Conversions involving mixed units. So this is where the author of the book starts to get into more of the approach that I'm using involving the fractions, or what's called the bracket method also. And this is just things like, if you take a look at this conversion here, we'll do similar ones. See, 80 feet per second to miles per hour. So you're not converting a singular unit of like feet to miles. You're converting a compound unit of feet and seconds, or feet per second, into miles per hour. So both the feet and the seconds need to be converted. So that's the focus of this last piece of the chapter. There are some very well written examples. I was actually the person that typed this all up, so that's exciting. But anyway, if you dip over to page 26, there's a whole bunch of questions here. There's 8 of them. And you can see that the author talks about 1 bracket or 2 bracket or whatever. And whether or not you do it exactly how they're saying, you can just follow the approach that I've shown you as well, which will work just fine. So let's take a look at question A. So here we go. This is again page 26, question A. I'll just type that here in case anybody asks. Okay, so we have here 65 feet per second, which represents a speed, and we want to convert it to meters per second. The good news is that the seconds do not need to be altered. That's why this type of question, it says needs only 1 bracket. It needs only one thing to be fixed, which is the feet. So if I go over here, I'm just going to double check the precision. It's doesn't say, but we'll go with 3 significant digits anyway. So here we have 65 feet per second I'm going to use the letter S instead of seconds because actually it's okay. My word processor thinks of sec as a special command. That's why, because of trigonometry. So we don't want feet. We want meters. So how many, what's the conversion or what's the equivalence between feet and meters? How many feet are in a meter? Does anybody remember from last time? How many feet are in a meter? Thank you, Marco. So where do I put that? Should I put that on the top or the bottom? Where do I put 3.28 feet? Top or bottom? It's actually the bottom. So the logic is this. The logic is this. You're trying to get, thank you, Marco. You're trying, and Nicholas, thank you too. You're trying to get rid of the feet. So you need a feet on the top and you need a feet on the bottom so that they cross out. So you always want to put the unit that you want to cancel on the opposite of the fraction. So on the denominator, you put on the numerator, or vice versa. So those cancel out, and yeah, 19.8, sure. I didn't calculate it. Can someone confirm that? Never mind, I just checked the answer key. 19.8 meters per second. Thank you, Nicholas. So in the next questions, we also have another, in the next question, we have another one, which is a conversion of acceleration. But again, because the seconds squared do not need to be changed, then you're good. You're good with this one as well. So instead of writing seconds, I'm going to write S, okay? That's not I just want to use the letter S because it just reads better on my word processor here on the PowerPoint presentation. So we don't want meters per second squared. We want feet per second squared. So we're going to multiply by that fraction, but because it's the other way around, we're going to put the feet on top and the meters on the bottom because we're trying to cancel the meters out. So let's cancel out those meters. When you do that, you get 32.2. I cheated. I looked at the answer key for that one. Thank you, Nicholas. So you get 32.2. Just on a random note here, for you are all most likely going to take Math 1146, which therefore has the potential of having me as your teacher again. But that aside, one of the lessons that I do in that course is I discuss the acceleration due to gravity. So this number is very famous. 9.81 meters per second squared, or equivalently, in the imperial system, 32.2 feet per second squared, is a very famous quantity and represents a constant that's used often in physics, which is the acceleration due to the gravity of the Earth. And so if you throw something in the air, it will accelerate downwards at that rate. Whether you want to use metric or imperial, it still has the same strength. Nice, Marco. Marco's on point here. This is all business. Marco, I like Marco. It's all business. We are good to go here. All right. So we have 40 miles per hour, and we want to go to kilometers per hour. So Marco, what's the conversion for that one? How many How many kilometers in a mile? Let's go with the one on the yellow sheet, the one that I highlighted before. I have it as 1.60, but they might have it as 1.61. I'm just checking the sheet here. So I just checked the sheet, and it's 1.61. Oops, wrong place. 1 mile is worth 1.61 kilometers. This is actually an interesting thing to remember. You know how there's the big track at the Olympics, the standard size, it's 400 meters. If you go around the track 4 times, that's essentially 1 mile. It's not exactly a mile, but it's essentially 1 mile. So when you go around a track, an Olympic track, a proper size track, that's actually called a quarter mile as well. It's 400 meters exactly, but it's also referred to as a quarter mile for that reason. This is very useful to know when you're traveling to the States as well, and you want to, or other countries where they use miles, being able to jump from one unit to the other. So anyway, are there any questions about that? Are we okay with the conversion there? Let me know in the chat. How are you guys doing right now? How's everybody doing? Thank you, Marco. And thank you, Maria, and thank you, Nicholas. I just saw the answer there. So 64.4. Easy peasy. That's what I like to hear. Lemon squeezy. You know that was coming. That was on the horizon. Okay, the next one here is a bit of a disaster. So now we're gonna do 5 questions. We're gonna do 5 questions that have more complex conversions in them. So in this case here, we have this is a density. For those that are wondering, it's density here. We have kilograms per meter cubed, and we want to convert to grams per centimeter cubed. So the fortunate thing here is that we are in the metric system, so I don't really need to look at a table because all the numbers are factors of 10 or powers of 10. We have 250 kilograms per meter cubed, and we need to make grams. Let me deal with the grams first, okay? So let's deal with the grams. I know that 1 kilogram is worth 1,000 grams. So that takes care of that. And now we have to deal with some more stuff. But just first things first, you take the kilograms and you convert them to grams. So now we have grams per meter cubed. By the way, you don't have to do it this way. I know there's people in this audience that can do this with way less writing. But just allow me to do it this way because it captures a broader audience in terms of the work. So in this case, we want meters cubed to turn into centimeters cubed. You could actually just let meters equal 100 centimeters, but you might get lost with the exponents. So this is the reason I'm going to do it this longer way and say that 1 meter is 100 centimeters. But notice that it's not cubed, right? We have cubed here. So this is not good enough. So you can take this thing here and you can write it 3 times, or you can just cube the answer. I'm not trying to make you do extra writing. I'm just showing you how if I lay it out with all the pieces, it might be easier for you to visualize. So now the meters cubed, you can clearly see there's 3 of them, and there they are, 1, 2, 3. And we have introduced centimeters, 1, 2, 3. So we have centimeters cubed with a really strange looking happy face. So if we clean that all up, I'm just counting zeros right now. We have 1,000,000 on the bottom and 1,000 on the top. So I'm going to say 0.25. Can someone confirm 0.25? Anybody else get 0.25? Anybody else get 0.25 there? Thank you, Huria. Thank you, Nicholas. All right. Just a second, everybody. I'll show you the next question and give you a head start. Okay, so here's our next example. We have another density question, but this time the density is going to cross over to the imperial system. So it's not just something that you could potentially just kind of finesse in your head. Because the previous question, I know there are people in this audience that could do that in their head. And if you really like, if it was like one of those action movies with the timer going down and you're going to save the world and all that stuff, I probably could do it in my head. But on a Friday morning, after a very long week of midterms, I probably would decline to save the world and just not worry about it. So I am not your action hero today. Someone else can be the action hero. Anyway, grams to pounds. What the heck is that? Anybody dig up a conversion on that? Grams to pounds? It's for sure on this sheet. I think I've seen it, like almost certainly. Yeah, that's right. Oh, grams though. 1 pound is right here. I'll take it from this sheet here, okay? It's right here. I know that many of you can't see that because you're like working on a different screen size. If you're wondering, I've got this little setup. I've plugged in my monitors, my television, and I made a stand-up desk. So there you go. 1 pound is 454 grams. That's a nice one to know. So we'll do that here. 454 grams in 1 pound. And you already did millimeters and inches earlier, so this should be light work for everybody, hopefully. So inches to centimeters is something similar. It's 2.54 centimeters for every 1 inch. And I'm going to copy it 3 times instead. I don't like putting brackets and cubing it. My concern is that you get mixed up with the exponent laws. So, can someone compute that? Anybody have a number on that? Anybody get that? Thank you, Huria. Beautiful. And the units are pounds per cubic inch. So when we examine the cancellation, I'll use a highlighter because the font is smaller this time. So here, see the grams? The grams cancel here. Those guys cancel. And then the centimeters here cancels with these. So these things in green are gone. And then what survives are the units that you want, which I'll circle. Pounds, inches, inches, inches. Actually, whoops. I'm not going to highlight them. It kind of takes away, I think. Okay. Well, there's only a couple more. After we're done these, I think we'll probably just call it an early day today. And for those of you that do have, there's a few more. Sorry, you can definitely go for yourself, or you can prepare for your test. As you can see, your professor does not know the alphabet, so let me just learn the alphabet for a second. There we go. Oh, I do know the alphabet sometimes. After 11 a.m., I know the alphabet. So anyway, Here we have 200 pounds per cubic foot. It's another density calculation. Are you for real? Okay. So if you're getting annoyed about that, it's because density is a very important conversion to know, especially in your field of study. So that's why you're seeing all these density conversions. So just 1 second while I clean this up. So we have here 200 pounds per cubic foot, and we want kilograms per cubic meter. So this time I'm going to do the conversion a little bit more compact, okay? I'm going to just, for those people that don't want to see all those brackets, all these things here, all these products, this is the shortest way you can probably write it, but still apply the strategy that I'm showing you. We want kilograms instead of pounds. So first thing is that 1 kilogram is 2.2 pounds, or 2.205 if you want to be a superstar. If you don't put the 05, I don't think it's going to be a big issue. I'm looking at my conversions, and they have it as 2.20. So I'll just leave it as 2.20, but I know there's a 5 after that. This is the part that I'm talking about. Instead of writing it down 3 times, for those of you that prefer to use your exponent laws, you can just write it once and then cube the whole thing. But just be very careful with your calculator power buttons and all that stuff. So we want meters and feet. So here, 3.28 feet for every 1 meter. So that should seal the deal. So remember when you do this, let's cancel out some stuff here. The pounds go away. The feet cubed go away right there. You might say, but it's only feet. But yes, but it's cubed. So this is the part that people will mess up. They'll forget that the 3 applies here, and it applies there, and it applies to the feet. So this is the reason that I'm a little bit hesitant to use this extra bracket with the cube. But if you're comfortable doing that, be my guest. If you feel confident that you're not going to mess it up, do it that way. And I did use the answer key here to save a little bit of calculator typing. But can someone confirm that the answer key, that this is the answer also for you? That's good. And the reason that I've rounded it a little bit is because it's 3 significant digits. So if you're wondering why is the answer a little bit off from what you have, it's just the significant digits. But your answer is perfect in terms of process. It looks better on the second line anyway. I was trying to tab it over and make it look nice. Okay. Okay, now we're going to calm down a little bit. This one here is, there's no cubes or anything weird. Excuse me. We have miles per gallon. So this is in the chat, what would this represent? This is not on your assignment, but in your assignment, in your first 3 questions, I talk about like, describe a scenario. So let me write a sentence as if this was the assignment, okay? This could describe fuel consumption in a car. Yeah, that's right. Fuel consumption in a vehicle. So that was based, because some people had emailed me, how much do I need to write on the assignment? Nothing intense. Just give me a sentence that's realistic. Like, don't put here, for example, this represents how much money I make each day, because that makes no sense. There's no dollars here. There's no time. It's just volumes and lengths. So anyway, back to business. $20 miles per gallon. It's a Canadian gallon. So miles and kilometers, we've already identified that as 1.61 kilometers per mile. Now we need to figure out Canadian gallons to liters. So 1 gallon Canadian is worth, where are you? .55 liters. So I had to look at that on the sheet because I don't remember that one. I know it's always forward a bit, but it's not like something that's ingrained because I don't use it every day. The last time I pumped gas with US with gallons is what, like 3 years ago maybe? So that's why. Anyway, 20 times 1.61. Thank you. Anybody else have that answer? I'm not seeing that. Unless I typed something wrong. I got 7. I got 7. That's okay. You probably just multiplied or divided the wrong sequence. Kilometers per liter. If I appreciate all the calculations everybody's doing because right or wrong, they're helping us get through this faster. And the last thing you want to have is me sitting here typing on a calculator, wasting 20% of your lecture typing on a calculator. That's it. You got it. Yeah. Trust me, I don't want to be the guy here typing on my calculator the whole time. I had a professor like that once. Spent the whole lecture with his calculator in his hand. It was just typing stuff. And I'm like, I can do that for you. Why don't you just teach? But anyway, it's all good. Okay, so 11.4 meters squared per hour. So we need to convert hours to seconds. That's easy. Hours to seconds. 1 hour is 3,600 seconds. If you didn't know that, you can do minutes and seconds and break it down smaller. But meters and inches is not one that we've done today, so that's good. So let's take a look down here. 1 meter is 39.4 inches. 39.4 inches for every 1 meter. I know that you have your next test in this course is not for some time. Probably another, if you do it correctly, I think it's another calendar month because we have 1 week off, then we have 2 weeks of class, and then your test. So really, your next test is in 4 weeks from today. And for that reason, I'll remind you about what I'm going to say now. When you do these questions on a test, I want you to use the table. See this table here that I'm circling around? And if you're like, I'm not going to remember the table or whatever, I will put the table in the PDF of your test. So when you're doing your test, I want you to refer to the table, or you can just print the table out on a piece of paper separately if you want to print that, because I don't want anybody just Googling conversions. Because when you Google it, you're welcome. When you're just Googling it, then there's no method, and I don't know how you did it, and I don't have any I don't have anything as a reference. Just try that calculation. I need to check something for 1 second, everybody. I apologize. It's related to the course, but I need to go to a different window on my computer. I did one extra. You're right. I just saw that now. My apologies. Okay, so now that thank you for the correction. So 4.92. I got 4.92 on the answer key. So I think that's it. I think we have what we need. Okay, so that's enough of the lesson. I hope that you had some fun, built up your confidence.